In this video, we're going to focus on enlarging an object. So again, we're going to use functions, but whereas the last video we looked at angle, and we already done center for motion, and angle rotates, the width and height are the things that enlarge it. So I'm going to start with something really basic. Again, if I just tie the variable a to these sliders, notice how as it slides towards 0, it shrinks. As it slides away from 0, in other words, as the absolute value gets bigger, it enlarges. But this doesn't necessarily make sense here. What I'd like it to do is what I'd like to visualize is the object kind of coming out towards us once soccer player Ronaldo kicks the ball. So once again, I'm going to actually borrow, since I don't want this thing enlarging until after it's kicked, I'm going to borrow my little piecewise function here, which means that it's not going to enlarge until it gets to the slider value -5. So its enlargement factor, I'm going to set that equal to 1. And again, this I'll have to change the name of this function. I used F4 last time. Let's call this F5. And I'm going to tie that enlargement, or you could call it a shrink factor too. I'm going to tie that factor to the width, but if I do just the width, see how it really distorts the image? It makes it just wide, but not tall. I'm going to tie it to the height as well, except I need to type F5, not F4, for my new function right here. So um, if you notice successfully, what I did manage to do is it's not enlarging at all, but right when it starts hitting -5, it starts going haywire. That's because my enlargement function doesn't make any sense at all. So what I'd like it to do is to be tied to, ooh, I have an A here. That is weird. That's funny that it's actually, oh, it's actually reading that fine. If I put an X here, it should read just fine too. But I want it to, once it's behaving just fine, for values that are less than the -5. But once I start getting past -5, I can make it like suddenly jump to twice the size. See how it just suddenly jumps to twice the size? That's an enlargement, but I'd like it to grow gradually and make it appear that it's coming towards us. So I'm going to want to tie it to the function maybe 2x like we did in the previous one. And again, you see how like we have here, we have 1, and there's this gap right here. That means there's going to be a sudden change here that's not really going to make sense, and I want it to grow. So I'm going to have to, again, shift this up by a certain amount, and I can do like the previous a video prior, I can sort of solve for it, or I can just do the guess and check method. And two guesses, it seems to be linked just fine. So let me actually play this through now. The ball gets kicked. Okay, and there we go. It flies out towards us. And if I wanted to enlarge faster, say you wanted to enlarge faster, well, you got to be careful because that'll throw off the little y-intercept. So you have to change your vertical shift, and you just kind of play with things until you get them right. 20 is too big, 15, 16, there we go. And so the most important part is when the ball gets kicked. So -5 is where I really care. But there we go. The ball gets kicked towards us. That is how to enlarge or shrink a figure in Desmos animation. So make sure you're tying it, whatever function you use to enlarge it, make sure you're multiplying it or tying it some way to your little width factor. And make sure, just like we did before, we want them to kind of intersect with each other. Again, since -5 is the point of interaction with the objects, you want the values of the two pieces of your piecewise function, if using a piecewise function, to agree with each other exactly at that point -5. Looking at the graph, it's really easy to kind of link them together just by guess and check. Like at -5, there's a break in the graph, and you just keep playing with the numbers until you don't get a break in the graph. This is how to do it using guess and check. That works fine. Or if you prefer to avoid the guess and check strategy, just make sure that the function, remember the function is the thing after the colon, like this is the first interval, and that's its function. And then the next interval is this right here. The part after the colon is the function there. Make sure that these agree each other at the point -5. So the value 1 has to agree with you kind of determine your slope first. So the 3x is just like the factor of enlargement, the factor of enlargement. That's how fast it enlarges. And then you solve for what value you have to like increase it by, or increase the amplitude by somehow. And so I can solve for that really easily. The x value again is going to be -5. So in place of x, put a -5. So I got 1 equals this right here, and so this becomes -15. Is -15 plus k is equal to 1. If you add 15 on both sides, that shows you where you get the k factor of 6. Alternatively, instead of just strictly looking for a vertical shift, you can look for like what do you multiply by this value for them to equal each other. And that creates, in this case, sort of like a shrinking factor. So like here, this thing shrinks and it kind of looks like it goes like backwards towards the beach. So you can also use multiplication, but oftentimes like a modifier by adding or subtracting might make more sense. But that is how we enlarge or shrink an object in Desmos.